and PSP the right way, parameter sniffing and dealing with parameter sniffing problems, I kind of felt like people wouldn't understand what the title really meant. And I'm kind of feeling that actually in here. And it's so funny because this is one of the most common problems I run into at customers. I see multi-purpose stored procedures, as I call them, in almost every client environment that I go to. And as a result, I have some solutions that will work incredibly well for these kinds of stored procedures. In fact, it'll work across all types of stored procedures and really give you the best benefit between recompiling too often or not recompiling enough. And I'm going to explain what I mean by that and show you a whole bunch of demos. In fact, I'm going to spend most of my time in demos, but I do actually have a bunch of slides as well, so that's why I'm hoping you guys might stay even longer, but I think I'm timed well, so we'll see. So silent cell phones, the obligatory slides at the beginning here. Make sure that you explore everything that PASS has to offer, and we do really appreciate your feedback. So at the end of the session, that would be great if you could fill out your evals, and there's all sorts of prizes and so forth as well. I don't even have an intro. I just want to dive right in. If you don't know who I am, come see me afterwards and I'll chat with you. But I've been doing this for a long time. I love SQL Server. I really do. I mean, it frustrates the heck out of me occasionally, but I do love this product. I've been working with it for over 20 years. So I want to get right to the problem. A problem that I've been seeing in SQL Server for, well, almost as long as I've been working with SQL Server. But the faster the boxes have gotten, the more users we've had, the more data we've had especially, the bigger and bigger the problem has become. So what I want to make sure that I convey is how stored procedures work in terms of caching and how parameter sniffing, which is actually not a bad thing, but how parameter sniffing can actually become a parameter sniffing problem. So I'm going to do this by talking about stored procedures, how they're created and how they're cached. I'm going to focus on one of the most common examples that I see in terms of kind of the generic programming strategy that's used out there that's horribly problematic. I'm going to talk about when plans are invalidated. I'm going to talk about how plans do get reused and don't get invalidated. I'm going to talk about parameter sniffing and go through when this occurs. And like I said, I'm going to demo this. And then I'm going to talk about when it goes horribly wrong. And the good news is I have a solution that's 100% to solve this problem. And that's the beauty of this. It's more coding. Your developers are going to have to change their programming paradigm for their multi-purpose procs. But if they can do this, it's going to have a profound effect on your server's performance and your long-term scalability of stored procedures, which should be kind of the cornerstone of what you're doing in terms of production. So I want to dive right into it. I've used this slide for years on how stored procedures are processed. When they get created, obviously SQL Server has to parse. They have to make sure that they understand syntax. They then are going to go through a process called resolution. However, many of you probably know that they skip resolution if any of the objects on which the procedure depends don't exist. Then, at runtime, they will always go through resolution, making sure the objects do exist, which allows you some benefits, right? You can reference an object that doesn't exist at creation that gets created by your application. So there's some cool benefits to that. But they then have to re-resolve, and then they optimize. And notice kind of the point that I made over here on kind of the left. I said execution if a plan is not already in cache. So what that means is when you first execute when there isn't a plan already in cache, SQL Server is going to then have to figure out what would be the best plan for that execution. And this is where things can be good or bad. The good side is if you have a very consistent set of parameters that result in a very consistent plan, then going ahead and looking at those parameters as they're passed in and deciding to create a plan based on them will be great for all of the subsequent executions. This is the concept of parameter sniffing. The parameters are looked at. The parameters are sniffed when that procedure is executed. Then they come up with a plan. They put that plan in cache, and all subsequent executions use that plan. Whether or not they should is a different discussion. They will reuse that plan. And what can often happen if the parameters that were first supplied are not typical, or if the parameters cause that procedure to wildly vary, then whatever plan gets into cache might be horribly problematic for subsequent executions. And wait till you see the demo I'm going to do on this. So this is the concept, the background. So in terms of stored procedure optimization, I've got kind of this slide to remind you of some of the key points, right? You don't have, or I should say, if there isn't a plan in cache, you get a plan. We know that. They don't save plans on disk. They never have. In fact, I've seen things incorrectly posted where people will say, oh, SQL Server stores plans on disk. Not the case. They really never have. They are in memory, and there are many ways that a plan can get kicked out of memory. And some of those are very obvious, like you bounce your box, right? You restart SQL Server, you're going to clear all the cache. Some people actually do this on purpose, and that is not going to be something I'm recommending. I want you to be able to leave that box up and running, and I want you to be able to control things a little differently. But you do need to be aware of the fact, and I'm not going to go into a massive amount here, but there are some other things that you might not expect that might actually clear your whole cache, like some configuration changes. If you guys do an SP configure on memory, even if you increase max server memory, which doesn't seem like it would do much, you actually invalidate and clear your entire plan cache. And it's important to kind of realize that because you want to make a configuration change that you think is no big deal and it's 10 o'clock on a Monday morning, you might have a pretty big impact on that server. As of 2005 SP2, which I know has been forever, right? But as of 2005 SP2, if you guys make a configuration change, the good news is there's output in the error log, 3 lines, that will actually say that your entire cache was flushed. So if you do a test of whatever configuration change you want to change on a dev box that's running the same, really the same version, the same service pack, the same CU, then you'll be able to know for sure whether or not that configuration option is going to cause your entire cache to be flushed in production. As far as database options, this doesn't make sense to me much at all, but if you change some file and file group options, like read-only, read-write, you clear the entire plan cache for that database. And that's true in all versions. There's some that have changed a little bit between 2012 and 2014, but my point here is it's another case where you might end up clearing your cache kind of unexpectedly, and that could become a problem. So you want to be testing these things out, even what you think isn't a big deal, just to see if it's going to have an impact. So you can have procedures that are aged out, they don't get used, and eventually they get kicked out of cache because they're not being reused enough to keep them in the cache. So those are very obvious. Schema changes should be obvious, right? You change your base table, that would obviously impact that stored procedure, so that's going to cause the stored procedure to get kicked out of cache, or procedures for that matter. Statistics. Oh my goodness, I had to create a whole slide on this one, not just because I love statistics, but because across the versions, the way they deal with plan invalidation has changed. I don't want to rabbit hole on this one. I put the slide in that has all the details, but it's kind of interesting that sometimes when you guys update statistics, a side effect is that your plans will get invalidated. That actually doesn't happen in every version. It's actually tied to a database option, and it's so strange. It's the auto update stats option, and if that's off, in some versions, your plans don't get invalidated even when you manually update stats, which is really weird, okay? So I have a whole slide on this, but the point that I really want to stress right now is if a plan gets put into cache, then subsequent executions use that plan. Again, whether that's a good thing or not is a totally different discussion. It's actually the discussion of the whole rest of my session. But this is what happens when that plan gets created and put in cache. Now, like I said, I don't want to rabbit hole on this one, but the invalidation side of things, in SQL 2012, statistics up, and higher, right? So as of 2012, statistics updates only cause plan invalidation if the data has changed, but it's not tied to the database option, which is good, okay? But what's interesting is if you suspect maybe a parameter sniffing problem, and you've historically had poor performance in the stored procedure. So here's the concept, okay? You have some stored procedure, it's not performing well. Somebody looks at the plan, and they see the estimate is off from the actual, because a lot of people will do this. Your first reaction, or a lot of people's first reaction, is usually, it's got to be the stats. So often, they will then update the stats. Well, then the side effect is very likely that the plan will get kicked out of cache, and the next execution, maybe even you sitting there testing it, might get a better plan, so then you get this positive feedback that updating stats solved your problem. So they wanted to get rid of some false positives, so they actually decided that if no data had changed, then they weren't going to invalidate plans. But they still update stats, which is kind of strange. Like, they're doing all the work and then not doing plan invalidation, and they already know that no data changed. But if you suspect a PSP problem, you won't get a false positive, unless at least one row has changed, which to me is kind of going to give you the false positives again. It kind of defeats the purpose. So it's interesting, and I just put this on here. It's really strange. You might have to read this one a few times because you might not believe it. I promise it's right. It just sounds wrong and seems strange. But there are cases where you, in your maintenance operations, should actually add an SP recompile to force the invalidation of your plans. And that can cause some other issues as well, including schema mod locks. And so it's really frustrating here, I have to admit. But I at least wanted to give you some insight into this and put the details in here. The long story short, I don't recommend turning off auto-update stats, but I also don't like SQL Server doing auto-update stats as its primary mechanism for updating stats. I want you to be controlling stats off hours, usually, right? And then kind of all this goes away, and that's the good news, right? Okay, and I do have a resources slide at the end with 3 or 4 blog posts to give you more detail on this, because it's so strange. Aaron's written a couple, I've written a couple. It's very interesting, very painful in my opinion. Okay, so let's get back to the point. If a plan is in cache, if it hasn't been kicked out through one of those methods, right? So if it's still in cache, what happens? Often people will tell me that they think that having the plan in cache is good, and reusing that plan must be great because we save CPU, right? We save compilation time, and we should get better performance. It should take less time to execute. All of these things are great. Well, that is good if the different parameters should have the same plan. But the stranger and stranger, or really the more complicated your stored procedures get, the less likely it is that they all should have the same plan. So as a result, reusing those plans can actually be horribly bad. And this is where I want to put my money where my mouth is, and I want to show you this, okay? So multi-purpose procedures. The problem that I really want to convey here is that a lot of developers, and I'm not picking on developers. I'm a developer at heart too, okay? I want to stress it. But the stuff that SQL Server does is not intuitive. And that's why I totally feel for you as a developer as well. The stuff that you have to do isn't intuitive, but if you do these things, you can get orders of magnitude better performance and a lot less resource utilization and waste. Because you're going to see in a second how crazy it can actually get. So my demo's here. Let me grab my, I only had like 2 minutes to set up, so I didn't open this up. But I'm going to give you guys an SSMSSLN, a solution file, and you can see just quickly what that looks like. So I've got a multi-purpose procs part 1, a multi-purpose procs part 2. My part 1 is based on a sample database that we use a lot. So I am going to actually restore it just to make sure it's nice and clean. This would be exactly the version that you get if you download our credit sample database. And then I'm going to set up for my multi-purpose proc. The first thing obviously was to restore. Then I'm going to tweak a few things specific for this demo. So what I'm doing, if you want to look at it, is I'm going to pull some data over from AdventureWorks. Now, if you don't have AdventureWorks, you can skip this step. But I wanted to, as many of your developers will do, simulate a little bit more data. And there's kind of a good and a bad here, right? Because often the data that they simulate isn't really real world. It's kind of a mess, you know, a mishmash of different things. And that's kind of what I'm simulating here. So I'm going to use credit. I'm going to bring over some data and then kind of convert it a little bit to fit more in with what this looks like in the credit database. Then I'm going to add a column that is called email. I'm going to add I'm going to update middle initials, basically taking their third character in their first name, and if it's null, making a Q. I'm just trying to set some values here, right? I'm going to add a couple of interesting rows, right? Oh, come on, you guys are no fun. All right. I should be doing nasty things to Paul's row like he does in his sessions to my rows, but I'm too nice for that. So I'm going to set an email as well by kind of taking their first name, middle initial, last name, and kind of munging it together. And I'm going to end up with about 30,000 rows. I'll show you a couple of, 1,000 of them kind of, every 100th row or so through the table. And this doesn't take long to run on my machine, okay? So you can see some of the data looks like it's kind of reasonable. I should have uppered the middle initial, but I'm telling you, this is what it looks like in your developer environments too, so I was just kind of leaving it and going with it. I've got some that have streets. Oh, come on. You know I speak the truth here, because you've all done it before, right? It's like, oh, I'll just take some here and take some here and mishmash this, and oh, there we go, there's my sample data. 30,000 rows, that's good enough, right? I know it. You guys might not be telling me the truth, but I know it. All right, but here, so you can see some of the data, and also, if you've ever looked at credit, some of the values for first names are randomly generated gobbledygook, so there's a whole bunch of kind of weirdness in here, and again, very much so on purpose. So now, I'm going to create the infamous multi-purpose procedure. So what do I mean by multi-purpose procedure? Now here I want you guys to tell me the truth. I really, really do, okay? Multi-purpose procedures are often what I call one-size-fits-all procedures, where the developer has this dialogue that allows the user to submit a customer number, a last name, a first name, a middle initial, an email, a city, a street, a zip, or any combination thereof, and they are going to code it with one stored procedure. And that one stored procedure is going to look like this. How many people have seen this before? Okay. Let the jury know that almost 90% of the people in this room said that they did it, right? I see it all the time. And this is the point. This is worse than most people think. So let me show you. I'm also going to add some indexes because it's very likely that if we're going to search on last name, we need an index on last name. If we're going to search on first name, we need an index on first name. Now, don't get me wrong. I'm not saying that these are the best indexes, but this is also a very common problem I see. Where clause index, where clause index, where clause index. So I do even say that in here. I've put a lot of comments into these scripts to remind you of all the things we're talking about. You can reproduce everything I'm showing you here. You can shoot me email if you have any issues whatsoever. I promise you, these problems are prolific. They're everywhere. So I'm going to use credit. You can see I'm going to add an index for first names, an index for last names, an index for email, and email's showing the little squiggly because I just added that column, so it's not an IntelliSense. It's fine. It's not going to error. And then here, member code, and then here is my oh-so-clever OSFA procedure, one size fits all, right? Here's my parameters, and then sure enough, okay, I've got my code, and that's it. So let's execute everything up to there. I'll just grab that whole first section, and you can see I've created my procedure, okay, up to there. And now let's execute a couple of executions. So if I execute, last name of Tripp, email address of, %27, that can't be good, right? But I execute these things, I get my data back, and as a developer, a lot of us would say, cool, I've got my data back, I'm good, I'm done. And, if you look at this, no, seriously, I mean, most developers are testing, and I agree with this to a point, most are testing the 0, 1 in many case. They're making sure it executes, they're making sure they get their data, and it runs reasonably fast, right? I mean, wouldn't you agree? I didn't even register half a second here. So I got 0 for 3 executions of varying amounts of data. To a point, I'm pretty happy, right? I'm thinking this works, it's good, ship it, right? No, I know you're skeptical, but this is kind of the thing that a lot of people go through. It works, it runs fast, we're done. Well, here's what's kind of crazy. This is what I really want folks to do a lot more of. I want you to actually do things like turn on the graphical execution plan. So I'll turn on the actual execution plan, I'll turn my IOs, my time, and I'll go back and I'll run those same 3 executions, okay? I run them. Now, there's always a little bit extra just turning on show plans, so be aware of that. But I go look at the plans, and I'm also going to be misled. 33, 33, 33, I just ran 3 things. and it's telling me all three were exactly the same cost. That's because they ran the same plan. The cost of the plan from SQL Server's perspective is the same. When you look at actual execution plan, you are looking at the estimated plan, not what actually happened. This is why we can tell that SQL Server's kind of lying by having added statistics time and statistics I/O. So going over here, I'm going to see that the first one was 78 I/Os and took 46 milliseconds. Obviously, most people are going to be like, yeah, that seems pretty reasonable. I'm not too worried about that. And I didn't even tell you about how bad that plan was yet. I'll come back to that if you were looking at that going, that doesn't look right. But 78 I/Os, 46 milliseconds. Look at this next one. Does that look like it's efficient on a table with 30,000 rows? I promise you, this table has less than 1,000 pages. I would rather do a table scan than 90,000 I/Os. But on my machine, given that I have 32 gig of memory, I have 8 cores, I mean, with hyperthreading and so forth, my point is my machine and most of your developer machines can deal with this. And they don't, I would even argue that a lot of developers might go, so it did 90,000 I/Os, 198 milliseconds, okay. You know what I mean? Like there's nothing really super compelling yet at this size of data. And that's what I'm trying to stress, is the size of data in a lot of development environments gives them a false sense of security that their plans are maybe more reasonable than they really are. And this is horribly not the case here. In fact, let me grab another script that has a whole bunch of different executions, but I'm going to do something a little differently as well. I'm going to tell SQL Server to essentially invalidate the plan for get member information, okay? And then I, of course, didn't do the use credit, so we have to do that. So I'm going to tell it to invalidate the plan for get member, okay? And I'm going to grab one of these executions, and it almost doesn't matter which one I grab, but like I'll grab this one. Because remember, if there's no plan in cache, then this is going to be the one that's going to dictate the plan that goes into cache. So I'm going to execute just this. Then I'll go over here, turn on actual execution plan, and I'm going to run this whole thing, okay? So now, kind of the question is, what happened? If I go over here, look at this, 7%, 7%, 7%, 7%, 7%, 7%. Okay, that doesn't seem to help me much because they all seem to have the same plan. If I go over to the I/Os, if I go over to my time, we'll start to see 290. 90,000, 290, 37,000, 290, 290, 3,389, 90,000, 290, 290, 37,000. And that was because I just happened to put the plan for query 3 into cache. So let's go ahead and let's recompile again. Let's invalidate that plan. And let's grab one of the really ugly ones that I know is super ugly, query 14. And then let's run this whole thing again. And you start to see kind of, they're using multiple indexes, there's a hash match intersection. Again, I'm not going to worry, but now there's a spill because SQL Server's estimates were wrong and the amount of data that it actually got was too high, so now we're spilling to disk. We didn't get enough of a memory grant. We have multiple issues going on here. And I can change which plan I put into cache by just changing which one I execute first after I recompile, and then I will get wildly different results in terms of the query plan. So I'm not worried about the plan as much as I am worried about the effect of it, okay? And let me give you a few key points, and then I'm going to show you actually most of the combinations. The first point and foremost is what runs in development might not run well in production. This is super important. I really, really want developers to have realistic environments, realistic amounts of data, but even in the absence of that, there is a better way to test your procedures. That's what I'm going to show you. So even if they don't have a lot of data, I still have solutions here that are much better than what they're doing today, okay? So data size and data quality does matter, right? It does matter, especially in test when you're doing performance testing. And the parameters that generate that plan have a profound effect on the subsequent execution. So this is what I just showed you. And I do have another little trick, and I did put a note on this one in here, and I do have it inside that script. So let's go back and let me finish that one off. There is kind of an interesting thing back in the original multi-purpose proc. This is where we had left off, right? We had talked about running a few executions. One thing that you can do if you suspect a parameter sniffing problem, because maybe the estimates are off from actual, like right here. Let's see, what was the plan I just ran? Oh, it was that intersection. Okay, so if I run with email address %27, right, .com, and I run this, I'm gonna get the current plan in cache, right? So we'll run that. And I run this and I kind of start looking around and I see estimates of, 297, but there's 1,034. Or down here, estimates of 8,500 and the actual 30,000. Like, this doesn't look right, right? The estimates seem off from actual. So maybe I think it's stats. Before you go and do something as expensive as updating stats, my trick, the first trick I want to give you, is to take the current plan, if you're going to be looking and you want to see, and run it against the same execution with the same parameters with recompile. And the benefit of running those two is that you should be able to see if there's a difference, but this is a problem too. This 51% is tied to how much they thought this was going to cost, not how much it actually cost, so you can't look at the 51, okay? You can only look at if the plan shapes are the same. Clearly, not the same. So what I'm trying to show you is that this plan was not defined for these parameters. These parameters warrants a different plan. Another thing that can show you, if you haven't looked at this, is in the properties window. Let me pin it. In the properties window, if you go over to kind of this leftmost operator, there's a parameter list, and you can end up kind of expanding painfully each one of them. I wish there were an expand all. Anyone know of an expand all? I don't think there is. But I'll zoom in so you can see better here. And you can start to see parameter compiled values and parameter runtime values, and you can start to see that, hey, this plan was not defined for me, right? So that's giving you some insight that this might be a parameter sniffing problem, okay? Not a stats problem, not a SQL can't figure out the query plan problem, but a parameter sniffing problem. Okay, so how do I solve it? So let me go back, okay? So this is kind of a cool little trick. You do need to know what's going on, but look at what happens. Now, I know this is kind of an eye test slide to a point here, and there's a lot of stuff on here. You guys will have access to all the slides for download, so you can spend some time looking at this. But what I actually did is what I was showing you in the demo. I changed which one dictated the plan, and then I ran all of them to see what the impact of it was. And you can see for things like query 4 and query 11 and query 14, they were doing index intersection, so they were doing a hash match intersection of two indexes. It was then spilling to disk because their estimates were all wrong, which is a more and more expensive plan. But here's the irony. The irony to this whole thing, which is really going to tick some of you off, I think, is that every single one of these, no matter what plan I put in cache, I could still run all 14 executions in about 1 or 2 seconds. So your developers on my machine, right, your developers, again, are still, maybe without even looking at all these plans, they're going to be lulled into this false sense of security that things work. And they don't. They will not scale. I promise you, this will hit a wall, and you'll get new hardware. And then you'll hit a different wall, and you'll get new hardware. And then you'll finally go, why do we have to keep buying new hardware? And it's because the code is so inefficient. So let me go on and actually show you. Oh, and I do have this multi-purpose procedure with different parameter script that you guys can play around with and kind of create exactly this scenario by switching which one you run first. So you guys saw how I did that. Now, I'm kind of at this point, I always feel guilty. It's like, is there no hope, right? What are my options? How much of a nightmare is this? And the answer is, well, you could execute everything with recompile. No, I'm kidding. Okay, good. Making sure you're awake. That's my test. But I have seen people document and people say that you should execute with recompile when you execute with atypical parameters. I don't know about you, but how many of your users are going to be smart enough to be going, I think these parameters are atypical, right? I mean, not going to happen, right? So no, that's fantastic for testing, okay? Now, you could try SP recompile. This is fantastic for testing. You try SP recompile, you kick it out, and then you see if, well, hopefully you get there first, and then you get a good plan. But remember, on a busy system, you might not get there first. So that's really not a production way of solving it, right? I mean, it kind of maybe temporarily solves it, but eventually that somewhat good plan might fall out of cache again, and a bad plan might get into cache, and things get horribly bad again. I mean, one of the most interesting scenarios where I had run into this is I had a customer that they had a great idea, phenomenal idea, but they weren't really DBAs. And they implemented things on SQL Server because it's so quote unquote easy, right? And then they took off like gangbusters, and they got more and more users and more clients. And they literally went through the scenario I told you about. They kept hitting walls, and they'd buy a bigger box and buy a bigger box. And at the point where we got involved, they were running, and this is years ago, but they were running on a 24-way with 128 gig of memory on a failover cluster. And their solution when their server was basically inaccessible, was that they would kind of look at each other and go, well, it's happening again. And then one of them would go, okay, I guess we should fail it over. And I kid you not, that was their solution at the time, because they didn't know what was happening. They didn't know about the DAC. They didn't know about connecting and kind of looking at what was going on. So their solution was literally fail over the failover cluster. And sure enough, once memory's cleared, problem solved. Right? I mean, not counting the amount of time it took to fail over and for their cache to get, you know, populated again, and for all the plans. Oh, total nightmare, right? So this is a huge problem, okay? Now, you could update stats. That might work, but I've already started to tell you that that doesn't always work, and it's too much work. I don't want you to update stats. There's got to be a better way, and unfortunately, updating stats is an incredibly common solution. How many of you guys have had kind of this kind of problem, and you thought maybe it was the stats, and you updated the stats, and you got that false sense of security, right? I'm getting a lot of hands. So it's definitely very, very common, okay? Now, what about option recompile? How many of you have used this? I know it, okay? Not as many, I'm surprised, or are you just not telling me? I do not have a problem with option recompile, except that it's had a horribly checkered past, has had tremendous numbers of bugs over the years, including even recent ones, and it doesn't always work the way it should, okay? So there is that. But outside of that, I know a lot of you use this, and it's, in a lot of ways, a phenomenal solution. It's so easy. You just have to put option recompile on the offending line of code. And even for that multi-purpose proc, as long as you're not running 2008 RTM or SP1, it actually works. Now, 2008 RTM and SP1, they had a second additional bug, in addition to the other bugs that I'm going to tell you about in a moment, that actually made that not even work. So, but outside of that, it's a great solution. All right. Pardon me. Excuse me. Okay, so let me tell you a little bit about what I'm really going to do here, and why I do love, and why I've kind of had this love-hate relationship with option recompile. But first things first, recompilation is what's going to allow the plan to get re-optimized. So ultimately, yes, I am going to tell you that we're going to need some level of recompilation here. But the key things I want you to be considering and thinking about are, what do we really need to recompile? At what granularity can we recompile so that we recompile as little as possible, so we pay as little penalty as possible for recompilation? And is there a way to not recompile every time, which is what option recompile is going to force us to do? So these are some really important things that we're going to talk about, and I'm going to show you in my solution. But let's kind of go to why recompilation is really fantastic here. If you recompile, then SQL Server can look at the parameters that are specific to that execution and pick a plan specific to that execution, which often means significantly less I/O and overhead. So all of those like 90,000 I/O plans, in the worst case scenario, you'd be doing table scans, which would be like 1,000 I/Os and not 90,000. So that would be kind of the worst case scenario. So in my case, since my system's so fast and my data set's so small, the cost of compilation versus the cost of executing a better plan is pretty close. It's kind of neck and neck. And so in my particular case, I might not even see a big perf difference. And in fact, you know, playing with the demo at this scale, when I was trying to create something you guys could really reproduce, I couldn't get a lot of perf differences at this scale, which is why I have a demo that's at a more realistic production level scale. And I'll really be able to show you some interesting things. But my point is, the cost of compilation is usually fairly low. And as your data sets get larger, the cost of executing a bad plan gets significantly worse and worse and worse. For that customer that I told you was failing over their failover cluster, when a bad plan got into cache, every execution was doing 6 million IOs for a procedure that was executed by every connection. So what would happen when this really bad plan kind of occasionally got into cache, they couldn't really catch it because all of a sudden, you know, execution, millions, CPU 100%. And they couldn't connect, they didn't know about the DAC, and their only solution, it was like, it's happening again, failover, okay? So it goes horribly wrong in bigger data sets. And this is why it's so important to have realistic sample data and realistic data sizes, because if you don't, you're lulled into a false sense of security that these OSFA procedures are gonna scale, and they don't. So I'm gonna show you this. This is kind of my quick and easy fix, which notice I hear say, I created my little fake hashtags, but works great in dev, scales well in production to a point though, not for the long term. It scales well in production in my little scenario. I've got a much bigger scenario in a moment. But I want to finish up this scenario and show you the solution easily with this one. So I'm going to call this multi-purpose procedure solution 1. And this is where, and let me unpin that. This is where I'm going to use credit, right? I'm going to go back and take that get member info procedure, same parameters, and instead of just doing my like or, I'm going to tack on optional recompile. Now again, I'll take that, execute everything up to the top, and now I'll just take a couple of executions like we were doing a minute ago, and now you can see, let's turn on show plan, okay? So you can see the first one did an index seek. I don't know how many of you were really looking at the plans before, but those OSFA procedures that aren't recompiled always do scans. And that causes you some major grief. When you do option recompile, you start getting seekable plans, which will drop the IOs radically. So this can be a huge gain. The next one did a table scan because that was that crummy, you know, garbage in, garbage out. You ask a bad question, there's not much I can do for you, right? So there's that. But then this one, right, this one was doing scans before as well, but now you can see this one's doing a clustered index seek, right? So this one is able to look up and just get to the data. So what I did is I ran all the combinations back to my slide, and just to show you, if you remember those numbers, and you can sit and look at them side by side, but none of them looked this good across all those executions, right? Let me just flip back, I'll show you. This one is a build, right? Look at some of those numbers, right? I have, no matter which one I was executing, there are multiple that have, you know, 90,000 in every single, this one 37, so maybe 3 isn't so bad. There's another 90, there's a 37, right? Do you see how no matter what I execute, I've got some bad plans in there and I'm spilling, I have all sorts of problems here. Whereas when I put in that option recompile, look at those numbers. I mean, this is significantly better. But now I'm paying this added penalty to compile every time, compile every time, compile every time. And because these are already so small and my machine is so fast, it becomes kind of a wash on the timing side of things. So a developer might not even necessarily think they should or shouldn't do this because they don't see a big perf gain, especially if they're not looking like at IOs and things like that, and if they don't know the effect that these are going to have long term. So I know this looks amazing if you look at the numbers. And yes, it's incredibly easy. I don't want you to be lulled into a false sense of security here. I feared that some of you might want to almost run out and change your code, but I don't want you to do that yet because I have a much better solution for this, and that's what I'm going to show you, okay? So just hang out for just a few more minutes. I have a much, because I know some people at this point are just like, I know I have this problem. Option recompile can solve this problem. I need to go, you know, and I know some of you have this problem. I have a much better solution, okay? Now, there are a bunch of options for recompilation. I only have 75 minutes, and for once in my life, I decided not to have 275 slides and keep myself on track here. And I'm still not sure I'm going to do it, but I'm working on it, all right? There are lots of other options. I could spend time on some of these. I decided to not have a slide for every one of these, but I created kind of a quick notes slide of some of the things I would and wouldn't do. And I'll explain some of the key ones here. So my quick notes. Don't ever use create with recompile, okay? Now some of you might be going, why? There's multiple problems with it. First of all, it actually doesn't work the same way option recompile does. In fact, I didn't even tell you this, but even execute with recompile doesn't work perfectly well for OSFA procedures, the one I just showed you. You do get a better plan, but you actually don't get as good of a plan as you get with option recompile. Isn't that interesting? So create with recompile and execute with recompile. I use execute with recompile for testing, but it's still not something I'd use in production, and I wouldn't use create with recompile in production either for some of the same reasons. There's even more reasons than that, like it doesn't put any information in the dmexec procedure stats or the dmexec query stats. That procedure created with recompile kind of becomes a little phantom procedure that you won't know anything about. That's not good. Stay away from create with recompile, okay? Now, testing and troubleshooting, I'm a big fan of execute with recompile and SP recompile. But I really want you to look at the more granular options. Now, if you really do decide that you want to recompile for every execution, you can go ahead and use option recompile, except for the bugs, okay? And there are multiple bugs in multiple levels, and option recompile has a horribly checkered past. It really, really does. I have a slide called the checkered past of option recompile. We'll see that in a second, okay? Something that always works, but it's way uglier, and I know some of you are gonna freak out about dynamic string execution and SQL injection, but I promise you that if you construct a string dynamically, you turn it into ad hoc statements, or you turn it into an ad hoc statement. And then SQL Server goes through a process where it looks at the ad hoc statement and it says, are you safe or not safe for caching? And let me tell you, the rules on a statement being safe are so strict that probably 99.99% of the time, SQL's gonna go, oh, you're not safe, and it won't be able to put a plan in cache, so it'll get recompiled for every execution. And you might think, oh, I wonder what those rules are. Well, let me just tell you one. One will be good enough. If a statement references more than one table, it is not safe. Okay, I mean, if you want all 31 of the rules, they just get stricter than that, right? And so this whole SQL auto-parameterizing and reusing a statement for subsequent executions doesn't happen, okay? This is why a lot of people say when you execute a dynamic string, it gets compiled every time. That's not actually a true statement, but because most of the statements aren't going to be safe, they will get recompiled every time, right? It's just not A equals B equals C, right? So I just want to make sure that that's clear. Dynamic strings always work in every release and don't have the bugs that option recompile does. So I do have to admit that that might be a better, albeit ugly, but better way to do some of the things I'm going to show you, okay? And what I decided is I am going to write a third solution. It was like a half an hour before my session, and I actually did sit down. Someone saw me, because I was out there feverishly coding, and I was going to try to create a whole new third solution that I could show you 30 minutes before the session. Not my wisest of decisions, but I didn't finish writing it. So I will actually finish that, and I'll blog that. In fact, if any of you guys ask a question, even on PASStv, I will combine the, well, depending on how many, but I'll take a sampling of the questions if there aren't 4,000 of them, and I'll combine those with a third solution, and I'll blog that within a couple of days, give or take, okay? But within, I promise, I've been much better. I actually blogged like 4 times in the last 2 weeks, okay? Yeah, Paul beats me if I don't blog, so. Anyway, okay, so I digress. You guys know we're married. Wait, that still doesn't sound quite right. Anyway, I digress. So, like it's okay that he beats me because we're married. Never mind, I'm not going there. All right, so these are my quick notes. I'm moving on, all right? So here's my checkered past of option recompile. And part of the reason why a half an hour before my session, I have not seen this particular bug in 2014, but somebody did blog like an hour before my session, which was when I was coming over here, that there is new bugs, or there are new bugs. They're actually regressions, very similar to the bugs that were in 2008 and 2008 R2, although there were more bugs in 2008 R2. But I know, isn't this crazy? But CU4 of SQL Server, which was released on October 21st, does solve this. So my code works on CU4 of 2014, but if any of you aren't running that, then you could have some issues, which is why I'm going to give you a third solution, right? Just in case you're not running the latest, okay? So, but it's crazy, and this is what my third solution is going to use. It's going to use a hybrid combination of dynamic strings and SP execute SQL, and I really have to stress that even the code is uglier, you know, even though it's uglier, it always works. And so ultimately, you might want to go with solution 3, because then you don't have to worry about the odd and very weird checkered past of option recompile and potential other regressions as we move forward. So I've written that code before, which is why I so quickly knew what the solution would be, but I didn't think we still needed it because they had solved so many of the problems in 2008 R2, but they've kind of come back in a couple of releases. So anyway, so let me kind of move on to one other weird thing. Option recompile or a dynamic string is actually required for a couple of features. A lot of you might not know this, but if any of you use filtered indexes, right, or if any of you use parameterized views, right, or sorry, not parameterized views, partition views, right, it's on my slide. I should actually read my slide. Partition views, what will end up happening if you don't recompile is, first of all, with filtered objects, you won't even be able to use the filtered object. With partition views, you will get what's called partition elimination, but you won't get correct estimates, which could actually significantly skew your plans and your execution. So there are some cases where it's not just a plan problem, but it's actually a feature problem if you don't use recompile. Like another place is choose. I don't know if any of you guys use the T-SQL capability of choose. Choose needs option recompile as well to function effectively. So there are places where you have to actually recompile just to fully leverage features. All right, so that's another tangent. I did want that to be in here as well. So now let's get back to my point, the whole point of this session, the multi-purpose OSFA procedures. You know, I know you guys have this, I know it's everywhere, and I know you don't want to rewrite all of your stored procedures. I'm aware of that. I don't want you to have to do that either. If you have a stored procedure and you look at things like DM exec procedure stats and you start to see that it's got a lot of executions, that's going to be a stored procedure that's more likely for me to go and look at, right? And that makes sense, right? I want to spend a little bit more time looking at those that are run really frequently and, right, take seconds when they don't perform well, right? If something's always sub-second, it always returns 1 or 2 rows, and the plan kind of slightly varies, I might not care as much, right? I don't have infinite amounts of time to change all 25,000 of my stored procedures, but I know which ones, sometimes on my 2 hands, right? I can count those ones that are almost swear words in the office, right? Those, I know you know what I mean, those stored procedures that are killing you. So you want to focus on those first, okay? And so, yes, you're going to rewrite it, all right? So let me kind of show you what I want you to use as the strategy, starting with the original one, and then I'll show you on a much more realistic, bigger environment what the actual impact of this really is. Okay, so this is, again, I'm going to use credit, and we're going to go and create the same kind of procedure, same parameter list, but this time it's going to look a lot more complicated. It's really not as complicated as it looks, and as your developers get used to this, they're going to find it incredibly easy to do, okay? But here's my parameters, And error handling, what a concept. I didn't even put that much in here, but I just said, okay, we need at least one parameter. And then I'm going to build a string that is going to consist of whatever it was that you wanted to select. And then whatever your statement is, this is a really simple one. I'm just doing a quick customer lookup, a member lookup. So we're just saying, give us all the member information for, and we tack on the where 1 equals 1 so that we don't have to figure out, do we need a where clause or do we already have a where clause, right? So we put that on so that each time for each parameter that is not null, we just tack on that one, right? So if member number has not been supplied, then we won't tack it on. But if they have, then we'll tack on member number equals that member number. And the same is true for all of the other parameters. Last name equals the last name I passed in. First name equals the first name I passed in. And I'm going to build my statement dynamically. And I know you might look at this and say, oh, but isn't that more work for SQL Server to build? Yes, but this is a tiny amount of time, especially relative to executing bad plans. Okay, you have to keep that in perspective. This is negligible. This costs virtually nothing. Now, what am I going to do that's really clever? Because this is my favorite part about what I'm showing you is right here. Think about, like, let me go over to another window and kind of hypothesize for a second. Imagine, let's make it simpler, okay? Imagine that a stored procedure has 3 parameters, member number, last name, and first name. That's it. So you could supply a last name, you could supply a first name, you could supply a member number, you could supply member number and last name. And in fact, this is why I only did 3 parameters, right? Because we could do, well, we could do member number alone. There's only 7, so this won't be as painful as it might seem. Last name alone, right? We could do first name alone. We could do member number and last name. We could do member number and first name. We could do last name and first name. We could do member number, last name, and first name, right? 7 possible combinations. But here's my question. If somebody runs a query that says, select star from table where country is USA, not very helpful. Well, I mean, depending on where you are, right? But if it's a lot of US data, not helpful. But then they say, and member number equals 1, 2, 3, 4, 5, doesn't the query become trivial? Right? Immediately. Very trivial query. So my point is if somebody supplies a member number, doesn't that make almost every other thing that they supplied moot? Because if they say last name has an E in it and member number equals 1, 2, 3, 4, 5, we're going to go look up 1, 2, 3, 4, 5 and see if they have an E in it and we're done, right? So my point is that if member number is supplied, which notice there are 4 places that member number is supplied, right? All these 4. So what that tells me is that these shouldn't actually recompile because they're going to have a nice stable plan. Why put the effort into recompiling them, right? I want to put a plan in cache, keep that plan in cache, and use that plan. Done. The only place where I really want to recompile is where they might supply a last name of Tripp, and there's only a couple of rows, but they might supply a last name of Smith, and Smith might not be the same plan as Tripp because it's not as selective, right? And so I want SQL Server to have this option. Or even worse, did you see my code? I had like in there, right? Which I know a lot of people do this, but now that opens me up to saying, where the last name has an E in it and the first name has an A in it, which there's nothing good from that, right? So there's no good plan. If I don't have SQL recompile, I'm going to get horribly bad plans here. So this is where the code, I think, is the most clever. If member number is not null, I'm going to set a flag for recompilation, not to recompile. And what I did at the very beginning is I went more towards I think we're probably going to recompile. But in some cases, we're not. And those cases are, if they supply, there we go, member number, done. Don't need to recompile. If they supply a last name that has no wildcards, or a last name that has at least 3 leading characters, I'm happy. Now, you might want to change that to 4 characters, 5 characters, that's up to you, but you get my point. I'm basically saying if they say where last name is TRI and there isn't a leading wildcard in the first name as well, we're going to go with a plan for that and put it in the cache. And same thing for email. They need at least a few characters there. And again, you could make this 15, whatever you want. But you see the point that I'm trying to convey here is that I am going to build a string, and I'm not going to execute it with exec. I'm going to execute it with SP execute SQL. Now, SP execute SQL and exec are not the same. Exec builds a dynamic string that acts as an ad hoc statement. SP execute SQL is what's called forced statement caching. It, like a stored procedure, has a statement, puts that statement into cache, and put its plan in cache. But remember that I've got 7 different combinations here. So I will at least end up with 7 statements in the cache instead of 1 plan for 1 sproc, right? You following me on that? So I will have some that are in cache and some that aren't in cache. And that's the beauty of having added the recompile, which notice here is using option recompile. What another solution could be, and this is the one that I will blog, is where if you recompile, you use exec of a dynamically constructed string with exec, but the problem is exec has some funky nuances. You can't use the same version of the statement you're using here. So I'm going to have to actually build an exec version and an SP execute version side by side, and then right at the end, go with the exec version or go with the SP recompile version, okay? And I can show you the base of that, but I didn't finish it, okay? So there is another solution here. This is by far the easier one, and I love this, and it does work in some versions, okay? But there are some versions that do have problems with this, and that's what I don't want some of you to run into. So let me go and create this. I mean, it works in 2014 CU4, but here's my proc. Okay, and I will go ahead and go up. We don't really need to select it. That's up to you. I use that for, well, let's select it because I want you guys to see it, okay? That's actually why I had it there. But let's run that first part so we create it. And then we'll go back down and see how this changes things with, just like we had before, a couple of these executions. So here's the statement that I just constructed. Select star from member where member number is the member number I'm passing in, and then parameter-wise, you can see that, okay? And there's a few other things I was passing back. And then you can see my row that I get back. If I do this for last name of Tripp and first name of Kimberly, you can see the way that this generates it is last name like last name, and first name like first name, and then I was just putting out last name, first name, and member number here, and member number wasn't supplied, right? So you can see, and then in terms of my plans, execute again, and you can see that I'm getting a nice plan where I'm doing an index seek for last names, right? You can see we're using the last name index because I did last name of Tripp. We can find that pretty quickly. We have an estimate that's close to actual as well. You can't see it, I kind of scrolled it off there. But my estimates are good, my plan is good, because this plan was really defined for these parameters, okay? So now, having said that, I can run a bunch of these. Like, let's run a whole bunch of them. And like just looking even at IOs, did I grab IOs? I didn't grab statistics IO in this particular case, but just to show you, we'll put that in and I'll keep that in here just so you can see it, right? I run all of these and I'm back down to, you know, these little tiny IO costs. Well, this one is probably one of those wildcard ones, but it's certainly not the 90,000s that we saw before, right? And in addition to this, I now have plans I can use in cache. But this data set is so small that I knew I wouldn't convince you guys. And I know some of you are probably going, I don't know if I want to spend the time to recompile and write this code because option recompile, just putting option recompile is so easy, right? I mean, if all you have to do is take the OS for proc, put option recompile in it, and you're done, it's kind of like, why would I want to rewrite all my stored procedures to do all of this work? So let me go back, and I promise I'm going to explain this, okay? Oh, actually, no, I lied. I haven't demoed it yet. All right, so here's what I did. I decided to create a bigger data set. And this, since the concept to me is around this concept of looking up customers, I decided to create a customers database with, and what am I at? It's like 40 gig, 27 gig for the log with all the stuff I was building, but the table's not so bad. I'll just do a quick disk usage so you can quickly see this. And you can see, okay, I have 9 million rows. In total, it's a couple of gig. Definitely not the biggest table you could ever have. I realize that. But way more realistic than my 1,000 page table, okay? And my 30,000 rows, even though 30,000 does feel like a reasonable number, you guys saw it's horribly unreasonable here. Everything works pretty well at that level. So 9 million should make a difference, right? So I remember when I first created this, I then, and I've got a bunch of stuff I have to show you to go through this whole thing. What I ended up doing is I ended up creating, and this was actually a huge amount of work, I ended up generating all the different possible combinations of parameters, and I put those into a table. That's not even in this database. That's generate params. Wait till you see this bad boy, okay? I actually generated, I'm not kidding, 253 million possible parameter combinations. Clearly, I have way too much spare time, okay? A lot of that was Cartesian products and taking wild cards and then one leading wild card, 2 leading wild cards, 3 leading wild cards, wild card character, wild card, and all sorts of different interesting combinations. But then I created more code that ended up going and walking through loops to grab a random number of parameters randomly from within the 253 million rows. As crazy as that sounds, let me show you one of the scripts. I do a few things so that we can time it at the very beginning, but then look at my script. This one grabs customer ID, 7,939,000 with a first name and so forth, and I've got thousands of these. And I do have 5,000 different sets across all 10 of those scripts. So they are different, it's not just the same script 10 times, it's actually 5,000 different combinations of parameters across each of these scripts. So I generated those.
How do you not have time to block?
I don't know. It's a great, how do I not have time to block? Smart Alec, you're fired. All right. Doesn't even work. All right, but okay, so then I decided to create this little problem script which goes ahead and creates the ugly version of the script, sets a batch run, and then I decided to prime this one to put a plan into cache so that I would know that it wasn't the worst possible plan I could get, and I never, ever was able to let this finish. I'm too impatient. I actually yesterday decided, you know what, I should just see how long that one takes to run. And it ran for 13 hours, and it was less than halfway done, and I decided to kill it. I was too impatient. And my machine, by the way, was 100% CPU for 13 hours. My office, it sounded like a jet engine was going off in there. It was like, poor machine. Okay, so I tried to run this, okay, and I never actually successfully got this to complete. That's how bad it was, okay? And then I have my solution 1 and my solution 2. Now, the beauty of this is I can actually run all of these live and show you. And it runs within a couple of minutes, as opposed to not even finishing half at 13 hours. I mean, if this is not compelling, I don't know what else I can tell you, because this is exactly what I see in production. You get to a point where you've just accepted the poor performance and you keep throwing new hardware at it, and since it's gotten like worse and worse gradually, you don't even really know how bad it's gotten, right? Until you're having to reboot your failover cluster, right? Because you've got no other solutions, right? That's how bad this is. So now, let me go out to my script window. Okay, so now, I've got the results of the weight stats, so I'm not going to do that one, but I did leverage one of Paul's weight stats scripts. So you guys can play around with this too. And you can see these scripts. I'll give you all of these. I started to work, like I said, on solution 3. I can show you that quickly at the end if I have a couple of minutes of time. And then I started to create these batch files. So let me show you what these do. Well, I'm not going to do the problem one, but I'll show you what these do. I think my font's big enough for you guys to see here. But I basically first set up the proc that is that proc I want to be testing. And then I do some interesting things so that I can time this, because I have a test runs table where I'm keeping track of the executions, the time, and a bunch of other parameters. So I have a batch set number of 1, and I realized after this that my variables are BS and SOL, which is pretty funny. And totally unintentional, okay? And I was way too lazy to fix it before I got in the session, but it totally made me laugh. All right, but anyway, so batch set 1, batch set 2, and then you can see the solution is solution 1, solution 2, solution 1. Well, sorry, this is all solution 1, and then I'll run it with solution 2, okay? And then we'll see what happens in the tables. So let me actually kick off the start all batches solution 1. And the first thing I do is I do have a pause in there as well, so that I know that it kind of did what I thought it did. So it sets up solution 1, and then I've got this pause, and then it's going to kick off all those other windows. So I'll go ahead and do this, and then I'm going to go ahead and bring up Task Manager, or someone criticized me and said I should have brought up Process Explorer, and I'm like, well, it's still going to tell me I have 100% CPU against all 8 of my CPUs. So you can just watch that here. And it's always fun when you put something that's moving on the screen, because I could just let this run for like 10 minutes and you'd all probably still be watching it, right? But luckily this only takes about 50 or 60 seconds to run. And you know, if you think that I'm paying a penalty for this, I'll maximize that so we just have this on the screen. And we shouldn't even see any blips anymore, as much as we should just get it to 100%. But this does not take all that long to run. But you can see I'm compiling and I'm running, and I've got my system to a point where it doesn't look like I can sustain a lot more, right? Because I'm at 100% CPU. So we'll let this run. There we go. It looks like they're starting to die down, and in fact, it looks like they have died down. So let's kind of look at what the end result of this is. So this is from my generate parameters database. Yeah, you guys won't be able to do this test scenario as effectively as me, because there's so many moving parts to it. I suppose I can try to create this so you can, but this was more complicated. You can reproduce a lot of this with the other scenario, though. But having said that, my generate parameters for the last test run, that should be solution 1 that we just ran. I didn't change the database. There we go. Right? So that was my batch run 22. You can see 536, so that was the one I just ran. And then across the executions, I'm looking at about 51, 52, 49, 52, 52. So these are the execution of the different scripts, right? And each one ran about 5,000 executions. There are a few executions that I commented out because they were even more evil, and I didn't want to wait for the execution just because it was so much data, and I wasn't trying to test data, I was trying to test compilation here. So I kind of went to a little bit lighter of a scenario. But you can see 51, 52, 49, 52. So now the question is, what's the end result of this if we go with the other solution, okay? So solution 2, and just to show you there's no tricks up my sleeve, I'm running exactly the same thing, the Procs batch 01, 5,000 executions with batch set 1, 2, 3, all the way through 20. And then solution here is going to be labeled as solution 2. And this is because if I run lots and lots of these, I could then aggregating across all of them to kind of normalize it across lots of runs and so forth, okay? So that's kind of why I did all of this. So I'll go ahead and I'll run solution 2, let that run. Go over and bring up, I hate when I do that. I'll just do it this way. Bring up perfmon, or not, task manager, sorry, and we'll watch. This does get me to 100% CPU as well. So you might be thinking, oh, well, that doesn't seem like we can sustain as much of a load here. Well, wait till you see kind of the end result of everything together, because that's where things are way more interesting. So I think probably the most compelling, though, is how much time this takes to run. Now, it does seem like, oh, it's taken about the same time. But we will look at the total time in a second, and you'll be pleasantly surprised to see, you see those drops? Seems to drop a little bit sooner than we did before. So let me go back over and show you the test run. Okay. Again, mine always grabs the max, and looking at the old results, solution 1 was about 50 seconds, right? So this one now should give us solution 2, batch run 23, 1739, right? So that's the one we just ran. And across this, 33, 33, 34, 31, 39. And my point here is that I've got almost 50% less time across, well, what is it? 100,000 executions. And Paul talks a lot more about weight stats in other sessions. I barely even want to step into that area. But there's some interesting weight stats as a result of this as well. So let me go back to the slides and show you a few things together as the result of this. But this alone should be incredibly impressive because I've actually just run the same amount. That, remember, originally was taking 13 hours for half. So let's say over a day this would have taken. And I got it down to 51 seconds by using option recompile. Okay, I know quite a few of you are like, ooh, I'm going to use option recompile. But my code took another 50% off of that, and it's using less CPU, which is going to make it a more scalable long-term solution. I don't want you guys to use option recompile everywhere. You will hit a wall. You will not scale. This will scale a lot longer, especially across things that are running thousands of times a second, which I know some of you have to deal with. Okay, so let me sum it all up, because I think I'm like almost on time here. All right, so solution 1, like I said, was option recompile. The time was about 51 seconds. If you looked at the weights, and I'm going to show you them in a second, I still have some parallelism, but you should have seen the crazy one that I ran overnight, what the parallelism and weights were. That was out of control. You know what? I'll change the next slide, and I'll put those in there as well. I ended up tweeting it at like 4 or 5 this morning. It was pretty funny, and people were like, that was crazy. But this one is 50% less time with less CPU. So let me show you weights, right? My average weights, right, 0.0434. I realize you're looking at those numbers. It's really small. But notice that this one is much smaller. And my weights on the queue, the CPU, and for running are actually lower as well. So I'm actually able to run more with less of an impact on my CPU, which is what's going to provide you long-term scalability. You really have to think this way, and it's not hard. I promise, it's not complicated. It's just a different methodology that you're not used to. Once you get used to, you're going to just wonder why you haven't been doing this all along. And I've been doing this for so long that I can't believe that more people don't do it. And it's not intuitive, I realize, but once you start doing it, you won't ever look back, I promise. It's so much better of a strategy. So yes, okay, I agree, you can get huge benefits for using option recompile. In fact, okay, I'm gonna say, go ahead and use that as a temporary fix, use it as a Band-Aid. You've got this problem, I know you do. Go ahead and put that in there, sporadically, here and there, for the worst problems that you have. But you want to go back for those worst problem procedures and fix them if you want to have long-term scalability for your servers. The benefit of the code I just showed you is that stable plans are cached. You're going to save time, you're going to save CPU, but your unstable plans are going to get recompiled for every execution, which gives you the best of both worlds, not compiling too much, but compiling enough so that you're never executing a horribly inefficient plan. And I could even take this further, like that scenario that I mentioned. If you supply like member number more often, that plan's going to be in cache, which is actually going to reduce your compilation costs even further, right? So your workload might actually even benefit more because you're not causing recompilation every time. I can't stress this enough. I really, and you know what? Send me mail. I love hearing the stories that you guys have with this. I promise you this works. I promise you get better performance, and I promise you it scales, which is about the best I can promise you because I've only got one more minute, which is I've got one slide. Oh my God, you'd think I timed this. This is actually good. All right, so summing it all up, different parameterizations can be handled, I think, incredibly easily and incredibly effectively. I don't think that code will stump any of your developers. I think they'll look at that code and they'll be like, oh, okay, I can do this. And they won't even be surprised by it. And they'll just say, okay, I won't write those OSPA procedures, I'll write this way. And that alone, if you're a DBA, it'll change your life. It really will. It will change your server's ability to handle procedures at scale. which you can't say more than that. So you'll take less time for your sales, you'll sell more stuff, right? You'll save CPU, you'll scale more, you'll sell more, right? Which is all good. You'll save power. I mean, you could make arguments that you might not need as big of a box. You might not be needing to buy a new box as quickly. And I can always make the point that if you can save power, you can save the world. So I'll stay for questions. Thank you very much, and I'll blog a third solution. Thanks, guys. Yeah.
My understanding is see, I told you. I know what he was going to say.
Pero vamos, ahí más